Welcome to DBA 110, Lesson 3, Query Security. In this lesson, you will focus on how we can use query-level security and role-based access control to keep our databases safe from unauthorized access. You will see how to use these concepts to help protect sensitive information from getting in the wrong hands. Let's get started. We're going to unpack query-level security and role-based access control, two powerful cybersecurity concepts that help manage who sees what in a database. We'll cover why they matter, how they work, what can go wrong if we don't implement them properly. By the end of this lesson, you'll have a solid understanding of why these practices are essential to protecting your data. Before we jump in, take a moment to think about how much you already know about query-level security and role-based access control. Are you already familiar with these concepts? Or is this your first deep dive? Reflect on that, because understanding where you stand now will help you get the most out of this lesson. Let's talk about what query-level security actually means. Basically, it's a way to control what someone can see or change through the queries they run in a database. Instead of giving someone full access to all the records in a table, you design queries so they only run the specific information they're allowed to see. For example, think about a teacher. They only need to see the grades of their own students, not the entire school. Query-level security lets us tailor data access this way, making sure people only see what they're supposed to see. To build on that, query-level security isn't about blocking people from accessing the database completely. It's about making sure the queries they use only reveal information that's appropriate for their role. For instance, a teacher might get access to a list of their own students' names and grades, but they shouldn't be able to see another teacher's class or private information like medical details. By carefully crafting queries this way, we're making sure that sensitive data stays secure and is only seen by those who need it. So why is this so critical? Well, without query-level security, users could accidentally or intentionally pull way more data than they're supposed to. Think about Social Security numbers, health records, or student disciplinary notes, data that's super sensitive. On top of that, laws like FERPA, HIPAA, or GDPR requires that data be protected and only shared with authorized people. Query-level security helps us stay compliant with these laws and reduces the risk of data getting into the wrong hands. Here is a real-world example that shows why query-level security matters. Imagine a teacher runs a basic query, like select all from students. That query will return every student's full record, including private details like IEP plans or addresses, way more than that teacher should actually see. But with a properly designed query, using query-level security, the teacher would only get information for their own students and only the fields they actually need to see. That's a huge difference in protecting privacy. Another core concept in cybersecurity is the principle of least privilege, or POLP. This principle says that the users should only get the minimum access they need to do their jobs. No more, no less. Why? Because the more access someone has, the more damage they can do if something goes wrong, whether it's an accident or something malicious. This principle is the key to protecting data integrity and keeping systems secure. To put this in context, imagine a school counselor who only needs to see attendance and behavior records, not a family's financial information. That's the principle of least privilege at work. Tailoring data access so that it matches each user's specific job responsibilities. This helps prevent leaks, misuse, and mistakes. Here's another concept, need to know. When we design queries, we should only include the minimum information necessary to get the job done. Laws like FERPA and HIPAA require that data sharing is based strictly on what each person needs to know, nothing extra. This way, we protect people's privacy, stay compliant, and keep our databases safe from misuse. Think of query level security as a digital bouncer at the door of your data. It's there to make sure only the right people get in, and they only get to see what's relevant to them. This keeps your organization in line with privacy laws, reduces the risk of data breaches, and builds trust with your users. It's not just a technical step, it's about maintaining the credibility of your organization. Let's talk about FERPA, the Family Educational Rights and Privacy Act. Imagine a teacher accidentally accesses disciplinary records for students they don't teach. That's a FERPA violation, and it could mean fines or even loss of funding for the school. It's a reminder of why query level security is so important to get right. HIPAA, the Health Insurance Portability and Accountability Act. Now let's think about a healthcare setting. A receptionist runs a query that pulls in medical diagnoses they don't need to know for their job. That's a HIPAA violation, which could lead to severe financial penalties and legal issues. Query design needs to ensure that only relevant data is shown to each user based on their role. Here's the key takeaway. Table design sets up the structure of your database, but query security is what keeps private data from being exposed. Without proper query level security, even the best designed tables could be bypassed by someone using the wrong query. Laws like FERPA and HIPAA make it crystal clear that we have to control data access carefully. No excuses. Let's switch gears and talk about role-based access control, or RBAC. This system assigns users to specific roles, like admin, instructor, or student. And each role has a set of permissions that determine what data they can see, what they can change, and what queries they are allowed to run. It's a great way to manage who gets to do what in your system. RBAC makes it easy to manage permissions by grouping users with similar needs together. For example, teachers might all have the same level of access to student grades, while admins might have a broader access. This keeps things organized and ensures that no one accidentally gets too much access or too little. But even with RBAC in place, it's still possible for users to get access they shouldn't have if queries aren't designed properly. Think about a scenario where a school employee sees disciplinary notes they shouldn't, and then they share them. That could lead to disciplinary action, legal trouble, and damage to the organization's reputation. Let's talk about a real-world disaster, the Equifax data breach. Attackers took advantage of a known vulnerability in a web application framework that Equifax hadn't patched. As a result, sensitive information of nearly 150 million people, including social security numbers, was stolen. It's a perfect example of how when one small oversight can have massive consequences. So what could Equifax have done differently? First, they should have applied security patches right away. They also needed better vulnerability management, intrusion detection systems, and regular security audits. So what's the lesson here? Basic cybersecurity hygiene, like patching software and monitoring systems, can save you from huge data breaches. Here's another important example, the MOVEit data breach. This one happened because of weaknesses in input validation and access control, things that could have been caught with better query design. It's a reminder that SQL injection attacks are still a serious threat, and we need to design queries carefully, using techniques like parameterized queries to prevent them. So how can we actually improve query security? First, limit who has access to sensitive queries. Use views or parameterized queries to control what's shown. And make sure you're logging query activity so you know who's accessing what. These steps help catch problems early and keep data safe. Let's talk about some practical tips. When designing queries that involve multiple tables, always double check your relationships and use joins wisely. Limit the fields you pull back to only what's really needed. No sensitive data like social security numbers or medical information. Add where clauses to keep queries focused and avoid unnecessary exposure. Basically, design your queries with privacy in mind. Also, avoid select all. Unless you really need every field, it's better to be specific. Filter results with criteria to avoid pulling back too much information. Mass changes like update or delete should only be run by trusted users. And always preview your queries first. Keep track of who's doing what with your queries by using an audit log. It's all about transparency and accountability. Over-querying is a real risk. If you're not careful, a single query could pull in way more data than intended. Always apply data minimization. Pull back only the fields you really need. Add selection criteria to narrow your results. Limit who can run mass query changes. And don't forget to document and audit query use. This keeps everything above board and secure. Now that you've reached the end of this lesson on query level security and role-based access control, think back on how much you knew about these topics before and how much you've learned now. Hopefully you're feeling more confident about keeping your queries and your data secure. Thanks so much for joining me for this lesson. Remember, good query security isn't just a technical detail. It's a cornerstone of building trust and keeping sensitive information safe.